All right, this is resources squared, or otherwise, hopefully. But also, not everything is a nail, nor are resources the hammer. Resources are more like the metal that we'll use to craft the tools out of. But before diving in, a quick introduction of myself. Online, you can find me at Novox Populi everywhere. On the right here is my link tree. So I got too many links now. So this presentation is going to have a lot of links. It's written to still be useful and have all the context when uploaded and read. However, when live, links aren't very helpful. So almost all links will be represented by QR codes, and most of what I'll be linking to is documentation and live demos. And like the QR codes can be squirrely, but I did test this with, oh, no, come back. There it is. Oh, okay, it was loading. Yeah. I tested it. So if your phone has a good camera, it'll hopefully be able to pick up the QR codes. But the QR codes are supplemental information, so don't feel like you need to be scanning them. But if you're someone who likes to be doing things while you're doing things, then they will be good for you to play with. Afterwards, the slides will be available on GitHub and published and viewable from GitHub pages. So you can wait until then to scan QR codes if you're curious about doing that. So this is my programming journey so far. I'm not going to read it, but the TLDR is that I've seen a lot of things, and I've been using Ember.js the longest so far. On the left here is a picture of my partner and favorite human. She is the best. Outside of programming, I like swing dancing and video games. And on the right here is a screenshot of my favorite VR game, Beat Saber. I only have one disclaimer about the things I'm about to talk about, mostly that there are gaps in documentation today. And that is including like learning materials on proper derived data, including resources and patterns with derived data and resources. And then we need to actually implement Starbeam for Ember. And if you're not sure what that is, we'll get into that in a little bit. But for those that stick to only what the official documentation recommends, this all may feel experimental and out of reach. But to help mitigate that feeling, I've been working on some learning materials and tutorials, and those are only increasing over time. I want to close all the gaps, and I want to try to answer everyone's questions, provide help, whatever you need. And the point of all this is to solve real problems more efficiently while also reducing the cognitive load everyone uh, just gains while writing their apps. It's extremely important that there are easy migration paths within the community. So programming is hard, and some migration paths are not and have not been so easy. The overall goal for everything I'm working on for and around this talk, resources, etc., is to be a polyfill for Starbeam, which I ultimately want Starbeam to be the resource implementation we use, as well as the implementation we use for all of our reactivity. But in this talk, I will demonstrate with the library Ember resources, because it's what you can install and use today. And any behavioral difference between my library, Ember resources, and Starbeam would be considered a bug. I'm committing to keeping support for Ember Source 328 for as long as I can, and I want to make sure that folks still on v3 can use the patterns coming in the future. And as far as I know, I think everything publicly available about Polaris is available and stable for use in 328. Getting back to it, with the introduction of Ember's first edition Octane, a new reactivity system was introduced, tracked properties. By the end of the 3x series and leading up to v4, we had two user-facing primitives, attract and functions. In Ember Octane, it was assumed that all reactive state, or root state, the very root of what auto-tracking was pulling on, would exist on a property in a class instance, which could then be decorated with the attract decorator. This use of a decorator allowed for a hidden getter and setter so that the reactivity system could operate while still allowing native property getting and setting, or without ember.get and ember.set, if you're familiar with those. We'll see how the secret value works later. In Ember Octane Ember 4, functions were called helpers. It wasn't until Ember Source at 4.5 that plain functions became supported as a reactive primitive without the polyfill. However, helpers, now called classic helpers, had two implementations, a simpler function-based version and a class-based version. These both required framework-specific abstractions to use and build. The class-based version of these classic helpers had cleanup capabilities, though awkwardly through inheritance. So what about modifiers or components? Fear not, I'll come back to these momentarily. And for components, I'm going to propose that they're not primitives at all. But first, I like to propose that we as a community rethink reactivity in general. Instead of attract, let's think of and redefine these as values, making the attract decorator a user of reactive values. And a value is the most basic kind of reactive primitive we could possibly have. These can exist within functions, outside classes, anywhere. This will be a theme throughout this new way of thinking about reactivity. For function-based helpers, we can use plain JavaScript functions. And supporting plain JavaScript functions as a reactive primitive, as well as their arguments, is essential for reducing the number of abstractions folks need to learn when they learn Ember. For class-based helpers, we can use a new primitive, functions with lifetime and cleanup. This allows us to compose our value primitives for managing state throughout the lifetime of the parent object, and then we can have optional cleanup, and we'll expand on both of those concepts momentarily. So for a couple of these, we still need abstractions because reactivity is not built into the browser. We'll call values cells, and cells will provide the abstraction with which we can build attract and allow us to use reactive values everywhere, not just classes. Functions we can leave as is because they directly access the state on cells. These will auto track and are completely transparent to the render, just like getters in classes. And these two things bring us into a great amount of alignment with the broader JavaScript ecosystem. So maybe you've heard of signals or runes. These two things are core in those realms as well. So functions with lifetime and cleanup are resources. These are key abstractions that I'll focus on for almost the rest of our time here. So a few slides ago, we hand-waved over the fact that attract abstracts a secret value. Here are the secrets behind the hand wave. The secret value can be thought of as a cell. So what is a resource? It is a unification of a lot of concepts. In Ember, they rationalize class-based helpers, modifiers, services, and routing. Outside Ember, they rationalize hooks and effects as well. They allow you to derive data in ways that previously you would need effect-like behavior. A resource is a reactive function, yet represents a value. It is bound to a lifetime and may have cleanup. So what does a resource look like? This is what they look like when using Ember resources, which you can install today, all the way back to Ember 3.28. You can do this. For this particular resource, we create a value, a cell. This represents the current date time. We can set up an interval and clean up that interval when the resource is cleaned up by whatever the parent context may be. In this case, it's a small component, but cleanup is block scoped. And lastly, the time is returned. The renderer inherently knows how to render cells as their values. So looking at this code snippet on the slide here, this is the Starbeam version, and the only thing that changes is the import. So we can also configure arguments, and this is probably one of the bigger differences between Ember resources and Starbeam. Due to how Ember's plain function invocation works, we need a wrapper function to handle receiving arguments. This is because Ember doesn't have public APIs for tweaking how plain functions are invoked from templates. It is intended to just be a function, though, as it is here on the bottom. This will This will just work as part of the process of implementing Starbeam. And there's nothing magic going on here that a user of this would need to be concerned about. When resources land natively, we don't need that resource factory that you currently do need in Ember resources. But I think there might be a way to create a Babel plugin to kind of use native functions and still have it work with the constraints of Ember's default helper manager today. But that's not implemented right now. If folks are interested in that, let me know, either working on it or being like, hey, that's a good or bad idea. But I would like to note that. So cleanup is useful for cleaning up event listeners, canceling observers, timers, disconnecting from web sockets, and maybe freeing up memory. Bunch of things could be cleaned up. So far, we've been looking at a clock example where the interval needs to be cleaned up. Let's take a look at another situation which may need cleanup. Now, cleanup in general is a concept we're likely used to. Components, modifiers, and class-based helpers all have a will destroy method. If you're the type of person who likes using features as they're released in the framework, you may have seen @ember destroyable. Cleanup is co-located with setup, and this is an improvement, but we can still do even better. So resources have more ergonomic cleanup. It is co-located with the behavior, which is a goal that will destroy methods didn't know to care about. There's no additional imports, which leads to greater IntelliSense and editor assistance around this API. So resources have a lifetime. What's a lifetime? As an application has a lifetime, it has a start and an end. During testing, oftentimes you'll have one application lifetime per test. It may even be a stripped down lifetime, only what's needed for rendering a component. But you can visit a route during that lifetime. That route could be thought of having a lifetime of its own, as well as the components rendered within that route. This recurses all the way through the rendering tree. Along and within that rendering tree, we may have a resource, or it could be a component or anything that fetches data for this route. When the parent lifetime ends, so do its descendants. When working with the framework, we often need to hook into the application owner for access to services and set up destroyable relationships so that they're appropriately destroyed when their parent is destroyed. If you've ever done this yourself, it is a lot of work. So here's what the code looks like if you wanted to link up a custom class to a component so that it gets the owner and has its destroyable method called when the component is torn down. We have @cached, we have setOwner and getOwner, and we have associate destroyable child. We don't want to do this. This is a lot of boilerplate. Resources do all of this for us. When we use a resource, it automatically has an owner. We get linked template invocation for free, and it automatically has the correct destroyable association regardless of where it's used. So when it's used in a template block, a component, or within another resource or a service, and that parent template block component resource or service is destroyed, so will that resource be also destroyed. So resources can easily be composed together. They abstract away the details and inner workings of the framework that would otherwise be exposed to your apps. Using our resource that represents the current time, now, we can define a new resource formatted now. We can compose now via the use function, and it renders in a component the exact same way. So data derivation is a pattern of managing the flow of data so that simultaneously rendering, testing, and maintaining is way easier. So if you're not familiar, derived data is practically defining what the data is rather than defining the reactions to that data and then performing some operation based on that. For example, on the left here is a reaction, an effect. This way of managing data will cause extra renders and performance loss. On the right, we have efficient data derivation via a getter. Now, many may be familiar with the problem on the left here. Um, you know you need to do something when some data changes. So you happen to know about these life cycle modifiers, but they feel kind of dirty because you don't really need an element, but you do it anyway because it's what you know and you might not know a better way. This is a leaky abstraction. It's not only goofy, and like we know this as we were implementing it, but the responsibilities of your function are leaking into the component. You can't unit test it because components can't be unit tested. Cleanup was probably forgotten, and you can't really interact with the this keyword on a component after an await when the component's been unrendered. But there is another way. With resources, you can simultaneously solve everything. Um, it's encapsulated, it doesn't require managing state on your component, and it can be easily unit tested. Okay, so why does any of this matter? Resources allow us to implement concepts that we are familiar with, but with greater ergonomics. They allow us to define how data or state is derived with the flexibility of optional cleanup. They represent values, as we've seen with the clock example, where the value is the current time. We manage the lifetime of modifiers if we want. We can also use them with services, routes, and not only do resources allow us to implement all of these concepts in a coherent and concise way, they rationalize class-based helpers, modifiers, services, and everything. They allow us to bring our reactive concepts to the broader JavaScript ecosystem, which is where Starbeam comes in and is the goal of Starbeam to be universal reactivity. So let's start with some examples of resources as values. So before diving into this example, there's a gnarly QR code here. It redirects you to a REPL or playground where you can mess with this example. So here the interval represents the clock, which has a number of problems. The time value is bound to a component, so we can't tear down our interval at any granularity smaller than a component. I'm sure you all have seen components that do too much, and this pattern kind of just adds to that. Also the teardown and setup are disjoint. So there's a life cycle, and you have to know about that, but since components lend themselves to be overburdened with responsibility, it's very easy to forget where the cleanup is, and it's easy to intermingle different behaviors, cleanup, and setup all over the place within the component. We've hacked a lifecycle event here via a setOnce property. The getter is still reevaluated every time _time changes. But if we were to add track data into this mix, we're at high risk of memory leak. Here we can already see that this looks way less complicated. Setup and teardown of the interval are co-located. The entire construct is focused on a single responsibility. Teardown occurs at the curly brace block scope level, where time is used, rather than at the component level. The lifetime of this resource is the curlies. And lastly, we don't need a bespoke lifecycle via setOnce property. Here's that code rendered. On the right, you can see that the time should be progressing. There we go. Yeah. So now let's compose this interval like we saw in some sample code on the previous slide. Here we compose using the use utility given to us by the resource, and then format the current value of the time resource. I've set up an argument receiving function so that you can so that we can use this composition to make it reusable yet configurable atomic concepts. And here's what that looks like. At the top here, the original time providing resource, and then you can compose it just underneath. This is using the Intel datetime format built-in utility, and we can render the current time in 4 different locales. In this example, let's say we want to move the most recent person. We want to know the most recent person to have visited Tatooine. the desert planet in Star Wars. We can assume that the method of retrieving the information exists, that the implementation might look a little something like this. This isn't a lot of code, but it does require scrolling. We can set up the socket and subscribe to messages. We can define how we want to format the last message, and then handle cleanup. Now, like with the other demos, there is a common theme of responsibility leakage. With components, it's very easy to accidentally make a component responsible for more than one thing. And what we want is a single responsibility concept that represents the value, the most recent person to visit Tatooine. Now, when using a resource, we have a much easier time managing socket information. Cleanup is straightforward and co-located. We can manage state in an encapsulated fashion. We can define a sort of getter for formatting the output. And this QR code here might be a little too bonkers. So here is what this looks like. And the demo is using the Star Wars API, which is free. It's pretty good. So here's the same as before. We have a long file, very long, and it's quite a bit of code. Let's see what it does. We're trying to handle loading state, error state, reactivity. We want to have a stable reference to the state, so at cached is needed. We also need to handle cleanup and also handle the abort controller. It's a lot. So when using resources, we can co-locate and focus on a single responsibility. This code doesn't scroll, and we can handle all the capabilities mentioned before: loading state, error state, reactively responding to URL changes, and canceling the request when we no longer need it. Here's the demo, which, there we go. The source code for this presentation has the direct link to this demo. QR code was a little too intense here. And there's a bit of extra code in this demo to allow it to be more interactive and demonstrate the reactivity of the resource. I'm mostly showing it to try to prove that this isn't smoke and mirrors. And what's super cool about using resources to manage data fetching is that you can compose them, just like we did with the current time, and you still get individual reactivity per resource. Here we configure remote data on 3 different endpoints, and note here that this uses an example util from Ember Resources remote data. Fear not, Ember Resources is a V2 add-on, so if you don't import it, you don't pay for the bytes. So when rendered, it looks like this. You can see that each request for people, planets, and starships takes its own amount of time to load. And it just so happens that the Star Wars API only returns 10 records at a time. And this can be as fine-grained or as combined as you want. Like some UX patterns may want fewer loading indicators than what you see here. All right, as a quick disclaimer, this is still in the works, still being figured out, and will hopefully be the foundation for the new routing system. Still very early though, so take things here with a grain of salt. In Ember, there are a couple of places to load components. You have routes and not routes. Loading data outside of routes is immensely useful when you need to otherwise be forced to drill props through countless layers of components. Resources can help eliminate the end user perceived difference between loading data in components and routes. Both places, routes and not routes today, allow for an easy problem to run into, though. Waterfalls. They request waterfall where large chunks of your app are delayed until particular data loads. While this isn't a problem unique to resources, it's a problem with naive loading of primary data within components, although we can solve it. So what should we do? We have the ability to have good developer ergonomics. In this example, we have the exact same abstraction being suitable through different styles of component authoring, but this abstraction needs some help to prevent waterfalls. I kind of see 2 paths to solving this. There's a runtime path and a hybrid runtime and build time path. The runtime path would use a backing service or maybe even solely Ember Data's request manager for having a shared unified request cache so that multiple components trying to access the same URL don't double up on work. That doesn't totally solve the waterfall problem, but the build time path is a bit more involved, but it could be implemented a number of ways, but hand waving, bunch of static analysis, it could like partly solve the waterfall problem. The possibilities are endless once you can statically analyze your components and render tree. We are in a really good spot for experimenting with solutions along these lines. So we've seen that resources can be wrapped in functions and reactively handle arguments. We can extend this to modifiers. This will be supported. No, this is supported in Ember resources right now. I think it's 6.4 or something. But here we set up an animation effect on an element. And the important thing is that this resource is the same as any other resource API. It's only wrapped in a function that receives an element. And then whenever args are passed to the modifier, this is the animation, what the animation looks like. Now, for those worried about bundle size, fear not. Ember Resources is a V2 add-on, so if you don't import it, you don't pay for the bytes. So we know that resources are bound to a lifetime, and that applications have a lifetime. This means that if we install resources on an application, the resource effectively acts as a service. We can define a resource that has some state. For brevity, that state will be a number, but it could be any service you can think of. With this resource, we can return a getter to get the current value, as well as a method to increment that value, but it just as well could be an instance of a class. We can then create a component, which then uses the counter resource here. Oh, sorry about that. Don't want to switch light mode and dark mode on you. The decorator is what does the linking between the resource and the overall application. Right here. So to demonstrate that the state is actually a service, I've rendered the component 3 times here. And here's a demo. You can see that all the buttons share the same state because that's what a service is for. All right, so can a resource also be a component? In React, it may look like this. Returning a template only or presentational or stateless component as their value, using the closed over function within the resource as the state. However, the main thing is that every framework already has legit component implementations, and those implementations are good at what they do. We can do it though. Now, as a caveat before anyone goes off and try this, the Glimmer VM is not designed to handle this situation. But it works. And you can check the QR code to like fact check me, but it's fun stuff. Now you might be thinking, you know, this good quote, but there are some advantages and disadvantages and trade-offs that we'll probably need to talk about later at some other time. So here's what the demo looks like. You can see that today that the resource still needs to be invoked like a function on line 24 there. If we only invoke it once, each time we render the component, the return from the resource, they share the same state. I don't know if this in particular has any use cases, but it's an important thing to note that this is a function that returns a component. We could adapt this to a component manager and have the invocation happen automatically for us, creating a new closure around the return component, but I don't yet know if it's worth it. This isn't something I want to ship unless people really want it. It would require a lot more changes than just what's in just some util in Ember Resources or some other library. Anyway. I mentioned this a while back, and I want to revisit the idea. Components are not primitives. Recapping the primitives, though, we know that from Ember Octane, And now that we've renamed some of the primitives that Octane introduced, we have values, functions, and we now have resources, which represent a value bound to a lifetime, and rationalized class-based helpers, modifiers, and services. And these can all be authored and shared anywhere. And that's the main goal of Starbeam. We can write our application logic once, our data fetching, UI logic, element modifiers, anything reactive, and use it. Not only in Ember, but React, Preact, Vue, Svelte, you name it. So components wrap the primitives. Components are refactoring boundaries. They are containers for organizing higher level concepts. So let's start wrapping up though. You may be wondering where the RFC is. Well, there's a draft here. It's very early, kind of just started because of procrastination and stuff. But it currently has the summary and motivation filled out, along with some equivalence comparisons between all the different APIs and syntaxes we have today versus Ember Resources versus in Starbeam. And that might currently be good information just to have. So the word resources may be a bit overloaded depending on your background. Ember Data Resources is an example project that can show you how to use resources to wrap Ember data for on-demand GET requests for non-primary data. Resources are also a concept in JavaScript itself. Here's a snippet from a TC39 proposal README that is in stage 3, or the implementation phase. The JavaScript resources have a similar purpose. They provide a means to manage the lifetime of an object. And Ember and Starbeam resources provide reactive implementations of this concept. And it may make sense for the implementation to build on top of JavaScript resources once they're shipped. And despite resource being severely overloaded, the alignment in behavior here does strengthen the word choice. Here's what it looks like in TypeScript if you're curious. Pretty cool. All right, so what's left? The main thing is I need to do more work with Starbeam itself. Need to get it into Glimmer. Need to ensure that there's parity between Starbeam and Ember resources. And need to add code mods for getting from Ember resources to Starbeam once that is in a place where it makes sense. And need to continue writing the RFCs. And yeah, I think, yeah, that's it. So TLDR, derived data is the secret to simultaneously performance and clarity, with some caveats around performance and data fetching. Resources help you model any situation as derived data. They are a universal primitive. And to get started, you can pnpm add. And thank you. That's all I got.